it and if feasible, adopt it. So we did it. It took 6 years that time to get it developed. There wasn't a lot of buy-in from industry. We had some pushback with respect to worker emissions and things like that. And again, in this case, the department looked at the benefits as being it conserved resources and it also would improve performance. So here's some numbers. We use it in friction courses and interlayers. DOT usage since '94, again, these are kind of ballpark numbers. We think we've used over 70,000 tons of ground tire rubber, which works out to be 7 million tires. Now, some good cocktail information about tires. The rule of thumb, I think, is somewhere that each person generates 1 waste tire per year. So in the state of Florida, what, 19 million people? That's 19 million waste tires per year. And in roughly 20 years, we've used about 1/3 of that. So we're not having a huge impact on the use of tires. It has real good cracking performance. If you look in that picture, the lane on the right, that's all cracked up. This is up in Bradford County. That's one of our earliest projects. That was no rubber in it. The lane on the left had rubber. So there's definitely engineering benefits, mainly in the cracking departments, not so much with rutting. So the usage with rubber has steadily declined since 2002. All right, we used to use it in probably 25% of our mixes, and it's dropped. It was 1.2 million tons in '94, 440,000 tons of rubber tons of mix containing rubber last year. So where'd the rubber go? Well, basically, if you look at this slide, in '94, we did about 4.9 million tons of asphalt. 2013, same amount of asphalt, but look at the polymer. Polymer has really taken off. And what it is polymer, it just is kind of a better material. There's nothing, it's not really a knock on rubber, just polymer seems to be a much better material. Asphalt's a weird material if you're not familiar with it. Normally if you do things to make it stronger so it won't rut, it cracks. If you do things to make it more flexible so it won't crack, it ruts. Well, with polymer you can do both. You make it stronger and more crack resistant, so it's kind of the miracle drug. So why the reduction? In general, we've had better pavement performance with polymer than with rubber. We've had improved cracking and rutting resistance, which we like that. I think we can make these stiffer pavements that won't make the car roll uphill. The polymer generally is better from an engineering perspective. There's also some handling issues associated with using rubber. The rubber wants to settle out of the asphalt binder, settles in a contractor's storage tanks, and then I get a phone call about once every 2 or 3 months from an angry contractor that they got to clean out their tank. The other thing is the cost of rubber is surprisingly higher than polymer modified asphalts. It's somewhere in the 7 to 12% higher than a polymer modified asphalt. So it's actually cheaper for us to use polymer. So again, not a lot of incentives there. So overall, we would probably say that the program is not overly successful, that there's really minimal incentives or driving forces to use it. From the department's perspective, again, there are some environmental, political, and some performance benefits. Again, it does well in cracking. From an industry perspective, though, it's basically a contract with a contract, compliance with a contract document. That they have to do it because we're telling them to do it. There isn't really a big incentive. So what do we do to take a program that hasn't been as successful as we would like it to be and make it a little bit better? So we're working on a solution. You don't need to worry about the details of the spec. We have a new spec that's going to basically try to make polymer modified asphalts meet the same, asphalt rubber binders meet the same requirements as polymer modified asphalt binders. It has to contain a minimum 7% rubber. We'll try to address the settlement problem, and our goal is to make rubber performance equal to polymer. So again, that's our goal in both the rutting and cracking areas. And then eventually we'll bid them both as options. So a contractor can choose. He wants to use polymer. If it's cheaper and he handles better, they can bid it that way. Much like Louis said that what they're doing in Louisiana. You've got the two choices. You can do A or B, and they're equivalent from the department. So we'd like to let the market drive the actual usage. So what do we see in the future, looking at the crystal ball, is we think cost of asphalt binder is going to continue to increase. It's going to kind of parallel fuel costs and oil costs. So because of that, I think there'll be an increased use of wrap material, reclaimed asphalt pavement. You'll also probably see in Florida over the next 5 to 10 years more use of recycled shingles. Jim Warren touched on this earlier. Shingles have about 20% asphalt binder in them, so it's another resource we could use. Concern with that is it's not really paving grade asphalt, it's roofing grade. It's a different animal, but we'll have to come up with a way to use it. The other thing is cost and availability issues with polymers. Back around 2008, we ran into some shortages, not only we had aggregate shortages, we had asphalt binder shortages. In some parts of the country, they couldn't get polymer. They couldn't get the B in the SBS. And that, I think, will create more demand for using rubber. And the other thing that we've noted is that these are very fledgling industries. And this last economic downturn has been very, very challenging for them. Some of them just barely hanging on. So if there's another downturn in the economy, they're going to be cooked. So anyway, last slide here. In summary, the department, I think Florida DOT, has been very committed to sustainability in our pavement materials. We use a lot of wrap. We use a lot of rubber. We didn't talk about it much, but we also use warm mix asphalt. And you'll see us start to use recycled asphalt shingles. The department generally feels that market-driven solutions are more effective than mandated solutions. However, we still need to maintain the same level of quality. The public wants to use us, I think, to be more sustainable, but at the same point, they don't want us out there resurfacing roads every 2 or 3 years. And with that, I think we need to take prudent risks. And thank you very much for your time. Thank you.
Very good. We have about 10 minutes for questions and answers here for the panel members. So please come forward if you have any questions about any of the presentations that, okay, we have.
I'm from the Mid-Atlantic area, and when I got in here today, I realized how nice, warm, and beautiful it is. And then I began to think, in your pavement selection process in Florida, is the pavement selection process affected by the urban heat island effect of the paving materials available? And if so, how do you factor it in? And if not, why wouldn't it be factored in?
Any takers, Jim?
Yeah, I'll take a shot at it. I'm not a pavement designer, but I did stay, in a Holiday Inn last night. No, I can tell you the department does not consider urban heat island effect in their pavement selection criteria. I'm not really sure why. I think part of it, I think there's a lot of debate over the validity of it, plus like in South Florida, we use white aggregates. So you drive on our asphalt pavements, they look white half the time as well. So short answer, no, we don't take that into consideration. Maybe something in the next 10 to 15 years, but not now.
Another questions from Sam here?
There's been a lot of discussion about the use of wrap in the asphalt, and this is a question for Jim and Dr. Muhammad, maybe to know what's happening in Louisiana, just to have another state. A lot of the asphalt contractors in the facilities in Florida right now are, to use a term we used to use in tunnel work, are muck bound. They have so much wrap, and they're not able to use it. In fact, one of the ironies now is that Florida is getting ready to be the second state in the country to build a concrete paving test road up in North Florida on US 301 and build a number of sections designed using different designs and also different materials. Several of those sections are going to be built using recycled asphalt as the coarse aggregate in the concrete. So my question is, in terms of to be more sustainable, and if you are going to be mandated to use ground tire rubber or shingles, which would perhaps cut down on the amount of wrap you could use, do you see the 25% wrap kind of holding, or is there innovations in new types of polymers or the term escapes me, for rejuvenators that would allow you to push that up so it now doesn't have to start going back into the landfills because you've reached that point and now you've gone over it where you're generating more wrap than you can put back in the mix? So where's the future of that?
Yeah, Sam, that's a good question. Basically, it's weird. If you're in urban areas, there's a surplus of wrap. Sometimes in rural areas, there's a shortage of wrap. But we are looking at ways to use more. I think from the department's perspective, we're trying to do things to encourage the use of more wrap material. We've got some sections up the NCAT test track where we're using polymer plus 25% wrap to try to bump it up higher and higher. You know, there's been work done up at NCAT recently that shows that mixes with, 40, 50% wrap are performing real well. So those sort of things, I do think there's better ways they engineer the wrap. They fractionate it now and kind of, instead of having one just big giant stockpile,